Alright, to find the optimal portfolio allocation, we need to find the correlation, the covariance matrix between our different assets. So the first thing we want to do is to find the descriptive statistics. So the easiest is to just use the built-in functions. So either you can click up here and find more functions and select it that way, or you can just start writing your functions. So I know it's called average in Excel. So I want to find the mean of this column. Push enter, and I should get the mean. And since I want all of these to just take the average downward, I'm just going to pull it to the right, and then just double check that, okay, it's taking the average of the correct values. Then of course you can just continue here. I want the variance. Now we need to be a bit careful, because now we have two options, variance S and variance P. So this is the population estimator, and this is the sample estimator. And this is a sample, so we want to use the sample estimator here. And once again, I'm going to highlight this column, finish off with the last parenthesis, push enter, and then I'm just going to pull this out to the right. And then we have similar thing for minimum. I'm going to just highlight and pull it out to the right. Maximum, highlight, and pull it out to the right. Oops, sorry. Okay. When we want to do this covariance matrix, we want to take this calculation. So we want to take the X data set, transpose it, and multiply it with itself. Now this is linear algebra. And divide with the degrees of freedom, sample size -1. So to get this X matrix, we need to demean all of these values. So I'm going to do this the XL way because it's the easiest. I'm just going to take equal sign. I want to take this value and subtract the mean. If I do this, then if I pull down, then the mean going to move down to the variance and minimum to the maximum. So I actually need to lock down this row. So I want this red one, the mean, to not move downwards. So I'm going to lock down the 20 by putting a $sign in front of it. The blue one I want to move down, and I want it to be moving to the right, so I don't need to lock down anything else. So I do that, I move this down, double check, did I get this value minus this one? Yes, great. And then if I set everything up correctly, then I can pull this to the right, and then it should move to the next asset and minus the mean. And then just double check, yes, it's moving correctly. So now I have the mean data here. I want the sample size, which I can find with the command count. And then I just want to count how many numerical values do we have. Push enter, and then I get a sample size of 16. So we have 16 observations of this data. So now I want to calculate the covariance matrix. I have this data. I'm going to name it X, just to simplify the calculations. I'm going to highlight the output now, and now I need to be careful here. So I want to take the X, which is this matrix, which should be a 16 by 5 matrix. So this is a 16 by 5, but it's a transpose. So it's a transpose, so I need to switch the dimensions. So this is a 5 by 16 times a 16 by 5. And then we're going to divide this with a constant, and the -1. Yes? So this means that the matrix, that the output going to be a 5 by 5. So this is Excel. So I need to highlight the 5 by 5 output matrix. I'm going to write equal sign. I want to multiply two matrices together. So that was ult. Array 1 is the transpose of X, semicolon my version, and X itself. And then I want to divide this with the sample size -1. And then remember now this is a cell array, so we need to hold Control Shift before we push enter. And then we have the covariance matrix here. So this is a bit cumbersome. Luckily enough, we have a tool pack now. And this is what we did in the first part, that we added these add-ins to Excel. So under data, we have data analysis and solver. So if we go under data analysis, click that one, we're going to bring up statistical calculations here. And we want to calculate the covariance. So highlight that one and push OK. Now I need to select the input range. So I can click this little arrow here and then just highlight the data. And notice here I don't need to demean it because it's going to do it itself in the calculation. So I highlight the matrix I want to use, the data matrix, push enter. Did I include labels? No, I didn't highlight these ones, but I could do that if I wanted to. And then you can either output somewhere in this spreadsheet or a new spreadsheet. So I'm going to just do it in a new spreadsheet. So I'm going to push OK, and then we get this output now. However, we might notice that these numbers do not match our own calculations. And that is because when you start reading up on this tool pack, you realize that they do not divide with n minus 1, they divide with n. So these are the population values, but we need the sample values. So we want to take this number, we want to multiply with n, which was 16, and then we want to divide with n minus 1, 15. And then we can pull this down and pull it to the right, and then we should get the same values as our own calculation. So 0.79, 0.79, 0.33, 0.33. So note here that we need to adjust the degrees of freedom to get the correct values here when we use the tool pack to do the covariance matrix.